Good day, everyone. Now we are in lesson 12, extreme values and optimization. One application of the derivatives is finding the maximum or minimum values of a function. A company owner may want to know the number of units of products to be produced to maximize the profit. An engineer might consider in his design of a tank what maximizes its capacity and what minimizes the scrap in the materials to be used for the constructions. The students may want to know what minimizes his weekly expenses. Such cases require optimization. Optimization is the process by which the values that would maximize or minimize another value are obtained. And now we can solve application problems involving maximum and minimum values of functions. Such problems are called optimization problems. Here are the steps in solving optimization problems. Step 1. Read and analyze the problem. Identify the quantity to be optimized or that would be maximized or minimized. Illustrate the problem if possible to facilitate analysis. Step 2. Write an equation or mathematical expression that would relate the quantity to be optimized with other given quantities using the known formulas or relationships derived from the illustration of the problem. Step 3. Transform the equation obtained in step 2 into a function having only one independent variable. Use the variable that is given emphasis on the problem. Step 4. Identify the domain of the function obtained in step 3 that would be most suitable for the problem. And the last, step 5, find the maximum and minimum values as described in the preceding topic. And now let's start an example 1. A rectangle garden will be constructed adjacent to a building. It will be enclosed by wooden fences using a 125 feet material, and that the side of the building will be one of the gardens perpendicular to the building. Find the maximum possible area of the garden. Step 1. So the quantity to be optimized is the area of the garden. So let's sketch the figure. So ito ngayon yung ating sketch. So ito yung ating building. Then adjacent to the building, meron tayong garden. And the garden is in rectangular shape. Let A as the area of the garden. And let X side of the garden perpendicular to the building. And let Y side of the garden parallel to the building. For the solution, step 2, write an equation for the area of the garden. Since the garden is in the rectangular shape, so the area is the product of its two sides, the X and the Y. Step 3, transform the equation of the previous step in terms of one variable. Since the wooden fencing material available will be used for the three sides of the garden, thus we have the equation as 125 equal to 2x plus y. So dito ginamit natin yung formula ng perimeter. Then solve for y, we have y equals 125 minus 2x. Using the given y equals 125 minus 2x, we can write the obtained equation for the area in terms of x. Since ang area natin ay the product of x and y, so we can substitute y to the area of the rectangle. So instead of A equals x times y, so we have area or A is equals to x, then substitute 125 minus 2x to letter y. Note that the area cannot assume negative values. Hence, to find the domain of the function for the area, we equate it to 0. Since the wooden fencing materials available will be used for the 3 sets of the garden, thus we have equation. Okay, so equate natin ngayon yung ating area na na-obtain natin sa step 3. Equate natin into 0. So, magkakaroon tayo na dalawang possible value of x. Yung isa ay x equals 0 at yung other one naman ay x equals 125 divided by 2 or 62.5. Therefore, the domain of the function for the area is close interval of 0, 62.5 or in between 0 up to 62.5. Okay, step 5. Now, to find the maximum area, we first find the critical values of A. So, we have A equals x times 125 minus 2x, or it is the same as 125x minus 2x squared. And that is, we get the derivative of A. So, ang A prime natin, so ang 125x, ang derivative niya ay 125. Then, minus 2x, derivative ng negative 2x ay negative 4x. The resulting derivative is defined at any number. Hence, we equate it to 0 to get the critical numbers. So we have A prime equals 125 minus 4x equals to 0. Then the value of x is 125 over 4 or approximately 31.25. Hence, the critical number is 31.25. The critical number x 31.25 is within the domain of the function. Now, we evaluate the area function at the obtained critical number and the domain interval boundaries of x equals 0 and x equals 62.5. So, ito na yung ating result ngayon. So, pansin mo dito sa ating table, yung 31.5 yung ating critical number. Then, ang ating close interval ay 0 and 2.5. So, paano na-obtain itong area natin? 0, 1,953.13, and 0. So, ang gagawin lang natin, we're going to compute the value of x to the given area. So, let's say for 0. A is equals to x. Ito yung ating area. X times the quantity of 125 minus 2x. So, let's substitute 0. So, A of 0 is equals to 0 times 125 minus 2 times 0 is 0. So, check. Next, area or A of 31.25. We have 31.25 times 125 minus 2 times 31.25. And we have 31.25 times 62.5. And the result is 1,953.13. So ito na ngayon. And the last, A of 62.5 equals 62.5 times 125 minus 2 times 62.5. And we have 62.5 times 0 and it is 0. Okay? So doon natin nakuha yung na-complete na natin yung table. Therefore, the maximum area of the rectangular garden is about 1,953.13 square feet, which occurs when its sides perpendicular to the adjacent building is 31.25 feet. And that's it. Okay, next example, number 2. A 16 inches long wire will be cut into 2x inches from one end. The x inches long part of the wire will be bent to form a square while the other part will be bent to form a circle. Determine where the wire should be cut so that the sum of the areas of the resulting figures is A maximum and B minimum. For the solution, let's say ito yung ating sketch. Ito yung ating wire. So yung isang part ay lagyan natin ng variable x. Then yung other part naman ay 16 minus x because the wire is 16 inches long. The quantity to be optimized is the sum of the areas of the square and the circle. So let A sum of the areas of the square and the circle. So we have A sub S as area of the square and A sub C as the area of the circle and X is the length of wire. The equation for the total area is A equals A sub S plus A sub C, which the sum is area is equals to S square for the area of the square plus pi r square for the area of the circle. The x inches long wire will be used to form a square. So we use the perimeter of the square. So perimeter P is equals to 4S and it is the same as XX. Okay, so to solve the solve for S, gamitin natin itong equality na to. So we have S equals to X all over 4. So pag ginawa mong all over 4, so cancel out ang 4. Then dito rin over 4. Kaya magiging S equals X over 4. Then we are going to use the result S to the area of square. So area of square is equals to S square. So we have X over 4 square and X over 4 square is X squared over 16. On the other hand, the 16 minus X inches long will be used to form a circle. So we have the circumference of the circle as 2 pi r equals 16 minus X. And to solve for R, ito ngayon gagamitin natin itong quality na to. So we have the R, maiiwan yung R over 2 pi. Cancel ang over 2 pi sa right side or sa left side. Then sa right side naman over 2 pi. Kaya naging 16 minus X over 2 pi. Then for the area of the circle, we have pi r square is equals to pi. Instead of r, we substitute the value of r. So 16 minus x over 2 pi square. So pag in-square natin ngayon ito, magiging 16 square minus 2 times 16 times negative x plus x squared over 4 pi square. Okay, check natin. So we have 256 minus 32x plus x squared all over 4 pi squared. Then yung sa pang pi factor. Okay, so pwede na ito makancel out ito, no? So kaya yung magiging denominator natin, 2 or 4 pi. Okay, so we have the area of a circle equals 206 minus 32x plus x squared all over 4 pi. Combining the resulting expressions for the areas, area of the square plus area of the circle. So we have the area for the square as x squared over 16 plus area of the circle 256 minus 32x plus x squared all over 4i. So dito sa case na to, ang magiging denominator natin ay 16 pi. Kaya magkakaroon denominator na 16 pi, then 16 pi divided by 16. Cancel na 16, meron pang pi. So we have pi x squared plus 16 pi divided by 4 pi. So matitira na lang 4. Then itong 3 terms na to, pwede natin itong rearrange. Ang gagawin natin mauna yung x squared minus 32x plus 256 times 4. Distribute mo lang yung 4. Then, pwedeng magkaroon ngayon ng common factor na x square. So, distribute mo natin yung 4. So, bring down x, 5x square plus distribute 4, 4x squared. 4 times negative 32, we have negative 125x. 4 times 256, we have 1024 all over 16 pi. So mapapansin mo itong part na to ay meron silang common factor yung x square. So pwedeng i-factor out na yun. No? Kaya ang mangyayari ngayon ay 4 plus pi quantity x square minus bring down 128x plus bring down 1024 all over 16. So ngayon, ito na ngayon yung magiging total area ng square and yung circle. The feasible domain is closed interval 0, 16. Then yung ating total area ay quantity of 4 plus pi x square minus 128x plus 1024 all over 16x. Then, ang gagawin natin, pwede natin i-factor out na yung 1 over 16 pi. The same lang naman. Tapos, kinuha natin yung derivative, no? So, kinuha natin yung derivative. So, ang derivative nitong 4 plus pi x square. So, bababa lang yung 2. Kaya nagkaroon ng coefficient na 2 times 4 plus pi x. Then, minus, ang derivative naman ito ay 28. Or, ang derivative ng negative 128x ay negative 128. Then, ito ay 0 na to, constant na yan. Okay? So, ngayon, equate natin ngayon sa 0 para makuha natin ang critical number. So, itong part na to ay magiging, 0 na to, no? So, kukuha na lang natin ay 2 times quantity 4 plus pi x minus 128 equal to 0. Okay, so etong 128, pwedeng dalhin ito sa right side na maging positive 128. Then, pag tinira natin yung x, itong coefficient na 2 times 4 plus pi, pwedeng maging denominator ng 128. Kaya ang mangyayari ngayon ay, ayan, na-transpose na natin yung negative 128. So, meron tayong x equals 128 all over 2 times quantity of 4 plus pi. And approximately, it is equal to 8.962 or 8.96. Okay, so ayan ngayon ang ating magiging critical number. Ito yung ating critical C. Then, lagyan natin ngayon sa table yung ating critical number 8.96 at yung ating close interval 0 and comma 16. So, kuhanin natin value ng A of x by substituting 0 or domain. So, let's start with 0. So, A of 0. So, substitute natin yung 0 square tsaka 0. So, mangyari na lang ay matitira na lang 1024 divided by 2 pi and it is approximately 20.37. So, 20.37 ang A of x ng 0. Next, yung 8.96. So, A of 8.96, balitan natin yung 8.96 square tsaka yung 8.96. So, numerator muna. Kinompute natin yung numerator, magiging 450.46 over 16 pi. Approximately, meron din tayong same answer din, 8.96. So, 8.96 doon. At yung last yung 16. A of 16, 16 square, tapos yung 16 sa isa pa. So, pag in-evaluate natin yung numerator, meron tayong 256 pi over 16 pi. Cancel out yung pi. So, 256 divided by 16 and that is 16. So, 16 din dito. So, na-complete na natin. So, madali na natin makita kung alin ang minimum value and the minimum value is 8.96. Therefore, the minimum value is 8.96 inches. Pinakita naman natin siya graphically. Ito ang kanya magiging graph. Obviously, pag tingnan natin sa graph ay mapapansin natin na yung kanyang minimum value ay nasa nasa 8.96. Okay?